Okay, within the topic of vectors, we're going to look at something called points dividing a line. Okay, this is really just when we've got a particular line on a plane and a point divides that line, and we are given the coordinates of the extremities. So if I was to say, for example, that this is the point A, which has coordinates 3, 2, and this is the point B, which has got coordinates 7, 14, and if I was to call that the point P, our task is then to find the coordinates of the point P. Okay. Now the way we do it is as such. Right, you take that number 3 and you multiply it by A. You take that number 1 and you multiply it by B. So in essence what you're doing there is you are multiplying together the opposites. Now from there you divide that result by the sum of the parts. It's really pretty straightforward, so let's have a go. Right, so the first move is I'm going to take that 3 and multiply it by A, the vector A. I'm then going to add on, and I'm going to take that 1 and multiply it by B, so 1 times B is just B. And then that all gets divided by, and I'm going to show this at the side, the sum of the parts. 1 plus 3 is 4, so I'm dividing by 4, so that is a quarter of that, since a quarter is dividing by 4. So it's then a quarter of, I'm just going to open up a rectangular bracket to make things a wee bit clearer here, because there's going to be a bracket within a bracket, 3 lots of the vector A, so I'm going to turn that into a vector 3, 2, plus the vector B, 7, 14, then just do a wee bit of arithmetic inside and tidy this up. So 3 lots of 3, 3 lots of 2, that's going to be 9, 6, plus 7, 14. Then that's a quarter of, 9 plus 7 is 16. At that point, I didn't really need that red bracket. 9 plus 7 is 16, 6 plus 4 is 20. So it's 1/4 of 16, 20, which is 4, 5. And my final move then is to write it back as a point, a position on a plane, and that is 4, 5. The point P is 4, 5. So let me just go over that again. So you multiply the opposites, 3 times A plus 1 times B. You then divide that by the sum of the parts. 1 plus 3 is 4, divided by 4, that's a quarter of. So it's a quarter of, and then open up this rectangular bracket, 3 lots of the vector A, 3 lots of 3, 2, plus the vector B, 7, 14, 3 3s are 9, 3 2s are 6, 9 plus 7 is 16, 6 plus 14 is 20, a quarter of that is 4, 5, and then finish it off by writing it as a point. Okay, let's try example 2. We're going to prove that P minus 7 minus 3, Q minus 4, 1, and R 2, 9 are collinear. And we're going to find the ratio PQ to QR. Okay, let's first of all do the collinearity bit, and that's from a previous video, remember? So PQ then is going to be Q minus P, and that is minus 4, 1, minus 7, minus 3, minus 4, minus 7, that's minus 4 plus 7, that's 3, 1 minus 3, that's 1 plus 3, that's 4, okay, so that's PQ. Okay, next move, let's find QR, which is going to be R minus Q, and that's 29 minus 4, 1. 2 minus 4 is 6, and 9 minus 1 is 8. Okay. So that is QR. Okay. So what we can see then is, well, from 3 to 6, 48, QR is double PQ. So QR is equal to 2 lots of PQ. There is also a common point, which is what? Well, it's clearly Q, so I'm going to go ahead and name that. Therefore, points are collinear. Meaning what again? Meaning that they lie on the same straight line. Okay. Right, so the next move is to find the ratio in which Q divides PR. So what I'm going to do then is put an illustration as to what might be going on here. It's always good to have a diagram. Let's say that's P and R. What we can see then is quite clearly the vector QR is double the vector PQ. So this line from here to here, this vector would be is double the length of this vector, which means it must be in that ratio. Alright, that is double, 2 steps in 1 step. So the ratio of P to Q to Q to R, I could then write that down as PQ to QR is, well, it's 1 to 2. Final answer.